Right, hi everybody. This is the start of topic 7.2, which has the title Causes and Impacts of Climate Change. Now, interestingly, when I've looked through the syllabus is very heavy on impacts, but there's virtually nothing, or I would maybe argue there is nothing about the causes, despite the title. So what I thought I'd do is I'd start this section with a video on the causes of climate change, which is it's kind of a bonus. It's an extra, I would say, if you're feeling charitable towards my videos. So before we go into the impacts, which is the main part of the topic, we'll talk about the causes. There's a third part to this topic, 7.2, which surrounds environmental value systems, and the syllabus calls it the debate around climate change. And I'll probably do that in a third video. Although in all honesty, I don't think there is a debate about climate change, whether it's occurring or not. I think that's a settled argument. So I think it's a little bit possibly disingenuous of the IB to refer to the debate. If there is a debate, I think it's between people that understand the science and people who don't or choose not to, or people that have vested interests in not believing in climate change. But I think we can cover that in a third video. Above my head, you can see the cause of climate change, which is the greenhouse effect. You can have a look at that now, but I'll come back to that in a couple of slides' time to describe why anthropogenic climate change is actually happening. What is the cause? Okay, so as usual, I've cherry-picked a few things from the syllabus, but in all honesty, I don't know if these things really describe causes. They're as close as the syllabus comes to causes, but even then, they're kind of moving towards discussing the impacts. So, well, let me tell you what I've picked from the syllabus and see what you think. So, number one, we need to distinguish there's a difference between weather and climate. It's a statement of fact, and you could argue again it's an impact, but it's worth stating. Climate describes how the atmosphere behaves over relatively long periods of time. The textbooks will tell you generally 30 years or more than 30 years. Whereas when we talk about weather, we're talking about effects over very short time periods, over days, maximum of maybe a week or less than a week. So that's the difference between climate and weather. Please don't confuse the two. And then in terms of effects, this is the closest I could come in the syllabus to what it describes as effects. It says that human activities are increasing levels of greenhouse gases, and these include carbon dioxide, methane, and water vapour in the atmosphere. And again, these lead to impacts, which we'll cover later, including changes in global temperature, increased frequency and intensity of extreme weather events, the potential for long-term changes in climate and weather, which we've already mentioned, and rises in sea level. I'm not going to talk about these sub-points in this video. That's something we'll come to in the next one when we do talk specifically about impacts. Okay, so I'm sure you already know from your general knowledge that the cause of climate change is global warming induced by gases that humans put into the atmosphere that we refer to as greenhouse gases. But it's just worth going over what effects these things actually have. The average temperature on the Earth is about 15 degrees Celsius. If there was zero greenhouse effect, if there was no greenhouse effect, we would expect the average temperature of the Earth to be minus 15 degrees C, which pretty much would mean that there would be no life on Earth. So therefore, a natural greenhouse effect is not only desirable, it's actually necessary for life to exist. The problem is the exacerbated greenhouse effect that humans are causing by the pollutants or greenhouse gases that we put into the atmosphere. The average temperature on Earth is maintained by gases in the atmosphere trapping heat, keeping it inside the atmosphere, and therefore allowing the Earth to reach this average temperature of 15 degrees Celsius. I'll come to the mechanism on the next slide. But at this point, I just want to say that greenhouse gases include, this is not all of them, water vapour, although we don't generally talk about that because the levels of water vapour in the atmosphere are stable. at least with a stable water cycle. So therefore, we don't expect changes, and therefore we don't expect effects of changes in the amount of water vapor to have an effect on climate change. Obviously, you know that carbon dioxide plays a huge role. Methane is actually more potent as a greenhouse gas than carbon dioxide, but we release it in smaller amounts. So carbon dioxide has a greater overall effect. Ozone, which is also can be stratospheric or tropospheric. It can either be close to the ground and therefore have effects on the air we breathe, or high up in the atmosphere and therefore have effects on the stratosphere or on global warming. Nitrous oxides, which are also put into the atmosphere by burning fossil fuels. And an interesting one is chlorofluorocarbons, CFCs. We don't talk about them much these days because following the Montreal Protocol, CFCs were largely banned. That wasn't because they were seen as having a big effect on global warming, but because they had an effect on the ozone hole. And you might be aware that it was the work of Mexican scientist Mario Molina that actually came up with this mechanism. And sadly, Mario Molina died last week. I'm recording this at the start of October 2020. Okay, so let's look at the mechanism. So I'll do a little sketch here to try to explain it. Radiation leaves the sun. All kinds of radiation, including infrared, which we normally talk about as heat, UV radiation, visible light, and all this radiation is fairly short wavelength, high frequency waves. Obviously much shorter than the waves I'm drawing here. These short wavelength waves are high energy. They hit the surface of the Earth, and the surface of the Earth absorbs some of this energy. Some of the energy is absorbed. So when it reflects, or the energy that is reflected as opposed to being absorbed, it's lost energy and it reflects as longer wavelengths. Now, many of these waves will escape the atmosphere and reflect back into space. But because they have low energy, they can be reflected back towards the Earth by the atmosphere, where the process repeats itself. Now, if the atmosphere is higher density as a result of us putting greenhouse gases into the atmosphere, we expect less and less of this radiation to actually escape into space, and therefore that results in global warming. You can see the same effect on the graphic above my head, and the reason it's called the greenhouse effect is because greenhouses do the same thing. Energy goes through the glass and hits the ground inside, and the glass panels inside your greenhouse, reflects with longer wavelengths, and therefore can't escape from your greenhouse, and therefore you have a higher temperature inside the greenhouse compared to outside. Okay, I hope that made sense. That's a fairly brief description of the greenhouse effect that leads to climate change. And the sources? Well, these are the main sources. Again, I gave a list on a previous slide. Carbon dioxide, obviously, which results largely from the burning of fossil fuels, and biomass, incidentally, wood and biofuels. The difference being for biomass and biofuels is that all of the carbon that is released was originally trapped inside the biofuels by photosynthesis during the lifetime of the plants. So it's carbon neutral, which means that when you burn biofuels or biomass, the carbon that you're releasing into the atmosphere was originally taken out of the atmosphere. Deforestation has an effect, not only in terms of reducing sinks for carbon, or the ability of living things to take carbon out of the atmosphere, but also a lot of the biomass that's chopped down in deforestation is burned. So big sources of carbon dioxide. Cattle ranching, cattle farming releases methane. It's seen as funny, but it's not really funny when you consider how much methane is actually released by cows. They're released from cows' guts in farts. And with the huge amounts of cattle that we farm these days, it has a very serious effect on global warming. I already mentioned that methane is more potent in terms of trapping energy inside the atmosphere than carbon dioxide. It's released in smaller amounts. In the Far East, paddy fields are used to grow rice underwater. And that method of growing rice encourages anoxic conditions in the sediments on the bottom where the rice grows. That results in the growth of bacteria that also release methane. We call them methanogens. So that's the second source of methane. And nitrous oxides, well, they're released from burning fossil fuels and also released by fertilizers, nitrate-rich fertilizers, which we've talked about previously as well. Okay, so those are various sources of the release of greenhouse gases. There are natural sources as well. There are even natural sources of CFCs, volcanoes. In fact, most of these gases are also released by volcanoes. But there's no doubt that the big effect that the Earth is undergoing at the moment is due to human release of what we refer to as anthropogenic, or resulting from human activity. Anthropos, genus, resulting from human activity. Okay, so I did mention that there is, or the IB postulates that there is still a debate surrounding global warming, or anthropogenic climate change, we could say. I disagree with that, and the reason I disagree with that is this famous graphic, which you're possibly aware of from watching Inconvenient Truth. The red line represents temperature. The blue line represents carbon dioxide in the atmosphere. And this graph goes back from the present day, 0, back 400,000 years, approximately 500,000 years. We can get data from that far back because we can get air bubbles from inside cores of ice. You can look at the carbon dioxide present in those bubbles, and the isotopes of oxygen that are present will also give you a record of the temperature at the time, because the temperature determines the makeup of the oxygen in the atmosphere. And if you look at that, there's a very strong correlation. In fact, there's no doubt statistically that there is a correlation between the amount of carbon dioxide in the atmosphere and the temperature. And then if you look right at the end of the graph, this is possibly a little bit out of date because I looked at the present accepted concentration of carbon dioxide in the atmosphere, and we're now above 400 parts per million. I think it's 403.9 parts per million is the accepted value at the moment. So you can see that carbon dioxide is increasing, and increasing it incredibly rapidly, which can only be explained from human release. So if the carbon dioxide level is increasing and the correlation is correct, we expect temperature to increase as well over the next 10, 20, 30 years. Okay, and then my final slide. This is the most up-to-date data I could get. It's from the IPCC, the International Panel on Climate Change, and it's from 2014. Possibly there is more up-to-date data at the moment, but I didn't find it just before I started recording this. So this is the accepted proportions of different greenhouse gases that are released by human activity. 76% is carbon dioxide, largely from fossil fuel burning. 16% methane, largely from cattle ranching, and I did mention paddy rice farming. 6% nitrous oxides from fertilizers, fossil fuel burning, and 1% from other sources. So you can see that carbon dioxide is expected to have the greatest effect just in terms of how much carbon dioxide we release compared to other greenhouse gases. Okay, so I didn't want to spend too long on this because it's, as I said, this is your podcast bonus. But I hope I've covered the causes of climate change in sufficient detail that we can start to put the impacts into context in the next video, or the next 2 videos. Okay, take care everybody, and we'll be looking at this in our class this week. Okay, goodbye.